You know how we explore for gas and oil. Now comes a moment of truth. We're going to drill a well. But first, there's some preliminaries. We've got to make arrangements for the land. And this is what's called making a lease. You see, someone owns this land. And one of the interesting things is there can be two ownerships to this land. First of all, there's a surface ownership, the right to build a road or a building. And secondly, there's the mineral rights ownership. That's the right to drill for oil or for ore deposits. And interestingly enough, those two ownerships may be separate. In fact, they are here. We're in the Osage Indian Nation right now in northern Oklahoma. Someone owns the land, but it's the Osage Indians as a tribe which own the mineral rights. It's the job of a landman to secure the mineral rights. And what he does is he tries to get the mineral rights owner to sign a lease. In return for signing a lease, the owner gets what's called a royalty. And a royalty can be anywhere from 1/8 to 1/4 of the gas and oil which is found on this land. Once we set up the lease, then we need to get a drilling contractor such as this to drill the well. The next thing he has to do is he has to prepare the site. He'll bring in a bulldozer, as you see like this, and he'll grade off the area. And they'll dig some pits for the mud. And now we're all ready to go. In comes a rig, and they're setting it up right now. It's time to start drilling. We're in the Anadarko Basin of southern Oklahoma, and we're going to go down about 7,000 feet looking for oil. On a typical rig like this, there are 4 basic systems. First of all, you have the engines, then you have the derrick, then you have the rotating equipment, then you have the mud system. Come on, let's take a close look at those systems. The rotating system starts with the swivel, which is located just below the traveling block. The swivel is designed to allow the pipe to rotate while still being hung from the derrick. Below the swivel, we have the first section of pipe, which is either 4, 6, or 8-sided, and is called the Kelly. The Kelly fits right in the Kelly bushing. Notice the wheels on the Kelly bushing. They're designed to let the Kelly slide on down through it. The Kelly bushing fits into the rotating table. The rotating table is connected by belt or direct drive to the engines. The rotating table gives the rotary motion to the pipe, and the Kelly allows the pipe to slip down through it. Each section of drill pipe is 30 feet long and is called a joint. Notice that the ends of the joints are all threaded, so the joints can be screwed together to form the drill string. After you've drilled 30 feet, you have to stop drilling and add another section of joint. The joint is added just below the Kelly. If you're drilling 6,000 feet, you may have 200 sections or joints in the drill string. At the very bottom of the drill string, we have these very thick pipes, which are called drill collars. These weigh considerably more than the drill pipes, and they're designed to add weight to the very bottom of the drill string. It makes the drilling much more efficient and more accurate. On the end of the drill collars, we have the bit. It's a very common type of bit called the Tricone. Notice that it has 3 rotating cones. The teeth on these cones are designed to chip and wear away at the rock. As the drill pipe is rotated, the cones rotate. And this is how a rotating system makes hole. The 4th system is the drilling mud system. What is drilling mud? Drilling mud is a very thick mixture of clay and water. Drillers call it gel. A rotary rig uses large volumes of drilling mud. The drilling mud system is a closed system. The drilling mud is forced through compressors and down a pipe. The flexible pipe then feeds the drilling mud down the swivel and through the center of the Kelly and the center of the drill pipe. It squirts out at the bottom of the hole, and then it returns to the surface in the space between the drill pipe and the rock wall. After it reaches the surface, it's taken over a series of screens, which are called shale shakers. The shale shakers remove the rock cuttings from the mud. The mud is then returned to a large mud pit, and from there it can be recirculated down the hole again. What's the purpose of the drilling muds? The drilling muds have two uses. First of all, the very thick drilling mud has an enormous amount of weight on the bottom of the hole. The weight of the drilling mud prevents formation fluids such as water and gas from leaving the rocks and entering the well. In fact, what happens is that the drilling mud actually forces its way into the surrounding rocks, and it plasters the surrounding rocks with the mud covering. This prevents the rocks from sloughing or falling into the well. The second use is that the drilling mud comes through the drill pipe and shoots out through this hole in the drill bit. It squirts across the Tricone. And what it does is it cools the bit, and it washes away the rock chips and flushes them back up to the surface. These are the four systems that make up a modern rotary rig. How do you know if you encounter oil or gas in the subsurface? One of the uses of the drilling mud was that its weight would keep the formation fluids in the subsurface. Rarely you hit what's called a gusher. The pressure on the subsurface oil is so great that it forces the drilling mud and even the drilling pipe out of the hole ahead of it. And the mud flows out onto the platform and sometimes even above the derrick. But this is very rare. The first time it ever occurred in America was in the Lucas well at Spindletop in 1901. Usually you have just 3 indications that you've encountered gas and oil in the subsurface while you're drilling. First of all, remember you usually have a mud logger on the job. And it's the purpose of the mud logger to examine the drilling muds as they come to the surface to see if there's any small amounts of hydrocarbons in the drilling mud. Secondly, remember you have a geologist that is well sitting. He takes a look at all the rock cuttings as they come to the surface, and he'll tell you if they contain any hydrocarbons. And thirdly, you can have the well logged. Electrical well logs will tell you if there's any hydrocarbons in the subsurface formations. But the only real way to tell if you've got commercial amounts of subsurface gas and oil is to run what is called a drill stem test. Here's how you run a drill stem test. You put a hollow drill stem down into the subsurface. Attached to this are 2 large packers. These inflatable donuts seal off the hole both above and below the formation you want to test. Once this is done, the weight of the drilling muds no longer affects the formation, and any oil and gas in that formation can flow out of the formation into the well and into the drill stem. Once the drill stem is open, the gas can flow right up to the surface, where it's usually flared. Oil rarely flows to the surface, but does fill to the drill stem to a considerable height. Once the packers are deflated and the drill stem closed up, you can bring the drill stem to the surface and measure the amount of oil in it.